Everybody, welcome to part 2. Now, I've already had an attempt at this and making a video of this, and then I realised that my camera was recording upside down. So after a moment of annoyance, I've realised I've had to start it again. So you'll see here there's already some working out, but I'll sort that out as we go. First thing I want to talk about though is how we can balance half equations, because this is going to be tested quite a lot in these questions. So a half equation. So here on question 9 is an overall equation. It's actually an ionic equation because there's a missing negative ion here and there's a missing positive ion here. They've had spectator ions removed. This is still, though, it's not a half equation, it's an ionic equation. A half equation, this is focuses on one of the reactants only. So this is a reaction between, well, there's some acid there, but then it's a reaction between manganate and chloride. It's a redox reaction between these two. A half equation would focus either just on the manganates, or the manganeses, sorry, manganese. It's manganate when it's got oxygen, it's manganese over here. So the Mn. Or another half equation would focus on the Cl-. So a half equation focuses on half of the reactants, either the chlorines or the manganeses. That's what a half equation is. It does one or the other. So when you're balancing half equations, there are 5 rules. 1, 2, 3, 4, 5. I can count to 5. Right, number 1 is write down any known reactants turning into products. All right, people forget that really easy step. Look at the question and write down some known things and stick an arrow in there. Number 2, balance elements. And this means balance any elements that aren't oxygens or hydrogens. Number 3, balance any oxygens with H2Os. Number 4, balance any hydrogens with H pluses. And then finally, balance any charges with electrons, negatively charged electrons. Now, you might know this already, you might be confused by this, so you have to see it in use, and that's what we're going to be doing now. All right then. So what I'm going to try and do is go through on this sheet, even though I've written the answers underneath, I'm going to go through it again. Right, deduce the half equation for the oxidation of chloride ions into chlorine. Right then, so write down any known reactants or products is rule 1. Write down any known reactants or products. So the reactants are chloride ions, so I would go chloride ions to chlorine, so I'd write arrow chlorine, and chlorine is Cl2. That's step 1. Step 2 is balance elements. There's 2 chlorines here, so I'm going to need 2 Cl- on this side. Step 3 is balance oxygens with H2O. There aren't any of them, so you can move on to step 4. Balance hydrogens with H+. There aren't any hydrogens, move on to step 5. Balance any charges with electrons. Excellent. So next step, if I look at both sides of the equation, this side has got 2 minuses, so at the minute it's -2. This side has got no charges, so it's 0. So I need to add electrons to one of these sides to balance out the charges. So if I add 2 electrons onto this side, this is now -2 as well. They are both -2. They are balanced. A common mistake that people make at this stage is to put the electrons on the wrong side, because they go -2 and 0, and they think, oh, I don't know why you think this. If I put 2 electrons on this side, that's now done. No, because you've now just made this side -4 and this side is still 0, so it doesn't work. You need to be careful, in other words. So if I uncover what I had written before, you'll notice it's exactly the same, and there's the answer. All right, the next question then. So I'm going to go here, cover it up. Give the oxidation state of the manganeses in MnO4-. MnO4-. Each oxygen is -2. So if I draw my little number line, I don't need this number line, but some of you might. Each oxygen is -2. -2, -4, -6, -8. -2, -4, -6, -8. The overall charge on the ion is -1. So I'm going to write -1 there, -8 here. So the manganese must do this. The manganese is +7. Okay, the manganese is +7. There's my answer there. So you got my working from before on there. Next question, deduce the half equation for the reduction of the MnO4-. So I've ticked this here because step 1 is write down any known reactants or products. All right, manganese ion. So it tells me the MnO4- in acidified solution. Acidified solution just means H plus and H2O. Okay? The MnO4- into manganese 2 ions. A manganese 2 ion is Mn2+. So that was step 1, writing down any known reactants or products. Step 2 is to balance any elements. There's one Mn, there's one NMN. I don't need to do that. Step 3 is balance any oxygens with H2O. There's 4 oxygens on this side, so I will need 4 H2Os there. And you go, yeah, just balance my oxygens. However, you've just introduced 8 hydrogens. So now you need to tidy up that mess by balancing that with 8 H pluses. The final step then is to balance charges. On this side, currently I've got 8 pluses and a minus, so that's +7. On this side, I am +2. So how do you get these two to balance? By adding electrons. Well, to get these to balance by adding electrons, you realise that if you minus 5 from this side, they will both equal +2. +7 minus 5. So if you put 5 minuses on this side, both sides now have an overall charge of +2. So that is your finished half equation. And there it is there for 1 mark. You've got to get good. Look, it's worth 1 mark. They don't give you credit for writing 4H2O if you don't write 8H+, and they don't give you credit for writing 4H2O and 8H+, if you don't finish it off with 5E-. Any slight slip, no mark. All right, A level is tricky. Right, in terms of electrons, what is meant by the term oxidizing agent? Not many, and Dr. Halides will say the same here. Not many of us just know the answer to that straight away, even though we've been asked it a million times. I go through these steps. Oxidizing agent gets reduced. Reduction is gain. Cool. Oxidizing agents gain electrons. All right. Oxidizing agents get reduced. Reduction is gain. Okay. Explain why chlorine has a lower boiling point than bromine. Right then, boiling points. Okay, chlorine is Cl2, bromine is Br2. Let's go firstly, ionic, covalent or metallic. Well, you're not metallic, you're not ionic. These are covalent molecules. Therefore, if we're dealing with covalent molecules, we are dealing with weak intermolecular forces, of which there are 3 types. There are van der Waals forces, permanent dipole, or H bonds. Right, do either of these H bond? No. Have any of them got a permanent dipole? No, they are non-polar molecules. So we're dealing with van der Waals forces. Why has chlorine got a lower boiling point than bromine? Because bromine is bigger. Br2 is bigger. It has more electrons. Therefore, stronger van der Waals, which take more energy to break. Okay, there you go. There's a bit of recap there. The halogens are the elements in group 7. The electronegativities of the halogens are shown in the table. Explain the trend in electronegativities shown by the halogens. All right, fluorine is the most electronegative. Chlorine is the next most electronegative. Right, electronegativity is the ability of an atom to pull electron density towards itself in a covalent bond. There's a little diagram to show that. So if you had H and F, the electrons in the covalent bond will be pulled strongly towards the fluorine. Just a little. In HBr, they'll be pulled less strongly, so they're only slightly over to the side. There's a little visual image of what electronegativity looks like. Okay, explain the trend in electronegativities. So as you go down group 7, where you've got fluorine, chlorine, bromine, and iodine, what happens to the elements? The elements get bigger. Fluorine, chlorine, bromine, iodine. So the elements get bigger. The elements get bigger as you go down the group. See, I'm showing you how I think this through in my head. The elements get bigger as you go down the group. So the outer shell electrons, or the shared pair of electrons, so this shared pair of electrons is going to be further away from the nucleus as you go down the group, further away from the nucleus. and more shielded from the nucleus, so bigger. So the shared pair of electrons in the covalent bond that we must be talking about are further from the nucleus and more shielded. Okay, and that's why the electronegativity decreases as you go down the group. I'm just going to have a little look at the mark scheme and see if I've nailed this, because I've not thought about electronegativity for a while. All right then, testing 10A. All right, they get bigger as you go down the group, so there's decreased attraction of the nucleus for the shared pair of electrons. Excellent, because we are talking about electronegativity being the ability of an atom to attract the shared pair of electrons in a covalent bond. I'm just going to have to pause the video for a sec, back in a minute. Right, okay, so the halogens can all behave as oxidizing agents. If the halogens behave as oxidizing agents, they get reduced. If they get reduced, so I'm going to write that down, they get reduced. Remember that reduction is gain. What this means then, I can rewrite that, reread it to myself now. The halogens can all gain electrons. Yeah, well, you know that from GCSE, don't you? Halogens gain electrons because they're in group 7, 287. They like to gain an electron and become 288 and gain a negative charge. I would encourage you just to read something in chemistry and then reword it in a way that you understand. The halogens can behave as oxidizing agents is a totally fine sentence, but it's easier to understand as the halogens gain electrons. Do you understand what I mean by that? So you don't have to... You need to decipher what the examiner is saying, because underneath it is a very simple concept. The halogens gain electrons when they react. Explain in terms of electron transfer the meaning of the term oxidizing agents. Oxidizing agents get reduced, gain electrons. Easy peasy. But I can understand why it's not easy peasy, because, you know, it's a skill to learn how to decipher these questions. An equation for the reaction that takes place when chlorine gas is bubbled. So I'm just moving through the answers over here. That's what the rustling is, just to make sure I get them right. An equation for the reaction that takes place when chlorine gas is bubbled. Just going to write this down. Chlorine gas is bubbled through aqueous potassium bromide. Aqueous just means dissolved in water. Potassium bromide is KBr. Is shown. Explain with reference to the oxidation states why this is a redox reaction. With reference to the oxidation states. No reference to the oxidation states, no marks. Okay, chlorine is 0. Chlorine ends up as -1. Bromide is -1, ends up as 0. I would write that. Chlorine goes from 0 to -1. I'll just write Cl rather than commit to Cl2 because it's not that. The bromine atoms go from -1 to 0. Chlorine that's numbers getting smaller, you could say, so it's reduced, and the bromine is oxidized. All right, that's it with reference to the oxidation states. There's the mark scheme, by the way. Chlorine 0 to -1, bromine is -1 to 0. All right. Next, solid sodium halides react with concentrated sulfuric acid. Now we're going to be doing something about this shortly. You need to be able to memorize the reactions of solid sodium halides with concentrated sulfuric acid, and I'm going to give you a really nice way to memorize that, but not now. We're going through this first. This will come next week when I get around to it. A sample of solid sodium iodide, NaI, is reacted with concentrated sulfuric acid, H2SO4. A black solid forms. Now, you'll find this out better when we do the topic, but the black solid that forms is I2, and hydrogen sulfide gas is H2S. Now, you know that because you haven't learnt this topic specifically, that's a bit of a barrier, but I think we should be able to get through it anyway. Write a half equation for the reaction of sulfuric acid to form hydrogen sulfide gas. Now remember what the rules with half equations are. Rule number 1 is write down any elements that you've got. In fact, I might even do a rule number half, which is draw an arrow. Draw an arrow, so you're committing to writing a half equation. The reaction of sulfuric acid to form hydrogen sulfide. Well, sulfuric acid is H2SO4. Notice how that's expected. They're not going to give you that. and it forms hydrogen sulfide, H2S. So first thing to do, rule number 2, is to balance any elements that aren't hydrogens or oxygens. 1 sulfur, 1 sulfur. Don't need to do that. The next is to balance any oxygens with water. So there's 4 oxygens here, so I need 4 waters over this side. The next thing is to balance any hydrogens. 8 hydrogens, 9, 10 hydrogens on this side, 2 hydrogens on this side, which means I need an extra 8 H+. This should become really easy. All right, next thing to do is balance the charges. There is no charge so far on this side. There is an 8+ charge on this side. Therefore, I need to make so +8 on this side. So I need to get this down to 0 by minusing 8. So I'm going to put +8 electrons in there. Okay, that's that one done. You notice I'm not like going, ooh, I think that's right. They're so straightforward. You've just got to learn that technique. Balance write down what you're given. Balance any elements, then balance oxygens, hydrogens, and electrons. Boom. I'm not even going to check the mark scheme. It's just right. Write a half equation for the right half equation. So you draw an arrow. There's rule number half for the formation of I2. So I'm forming it from I minus. Okay. Rule number 2, balance any elements. 2I minus. Rule number 3, oxygens no, hydrogens no. Balance any charges with there. Boom. I'm not going to check it, it's right. Use your answers to parts C1 and C2 to write an overall equation for the first 2 half equations. Right, so this is a separate skill that you're needed. Once you've got 2 half equations, you've got 2 halves of the puzzle. So if you've got 2 half equations, what you need to do is join 2 halves together to make a whole. So what they're asking me to do here is, here's one half equation, here's the other half equation, and now, oops, gone blurry, and now what you need to do is to join these 2 together to form a whole. So this half equation is gaining 8 electrons, and this half equation is losing 4 electrons. The first thing to do is to make sure that the number of electrons lost equals the number of electrons gained. So what that means is you look in the top equation, you see 8 electrons, and you look in the bottom equation and you see 2 electrons, and you have to make those numbers equal. So to make them equal, I'm going to times this whole equation by 4. What this will do, it will give me 8 electrons here, it will give me 4 I2s, and it will give me 8 I minuses. Now you'll notice that there are 8 electrons in the top and the bottom. All right, in the exam I wouldn't be changing it on here, I'm just doing it because these equations are handily placed. Once these electrons are the same in both equations, I can now combine these 2 halves. So combining these 2 halves, I'm just going to make sure I don't miss anything. 8H pluses, plus, I'm going to write the electrons in. I'll show you what I'm going to do with them later. You don't need to write the electrons in. Plus H2SO4. Then there's my arrow. Other things this side of the arrow, plus 8I minus. There's everything done there. Tick, 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 tick. There's all of the reactants, and the products are H2S, this one, plus 4 H2Os, that's that one, plus 4 I2s, that's that one, plus 8E minus. Okay, so not finished yet. Final thing to do, get rid of that, get rid of the electrons. Actually, that looks like I've highlighted them. Get rid of them, get rid of them. All right, and the very last step, which a lot of people forget to do, is just to see if there's anything, if there's like waters on both sides that you can cancel out, and there aren't in this case. That's the overall equation then. So when you are looking at joining half equations together to form whole equations, and I know you've seen these in the notes provided by Dr. Halides, that's what you do. You look at the half equations you've got, you make the electrons equal by multiplying one of the half equations, or both of the half equations if needs be, and then you join them together. All right, you might need to rewind the video and see what I did there. I don't know, that's up to you. Give the role of the sulfuric acid. Now, questions like this come up quite a lot. So typically the answer, if it's to do with a redox question, you're looking at reducing agent, oxidizing agent. So yes, it could be an acid, but no, this is acting as an acid, the H pluses. I think there's going to be something else going on here. So what I do, I revert to this very simple idea of going into oxidation states. They're -2. That's -8. The sulfur here is +6. The sulfur here is, that's +1, +2, -2. So the sulfur has gone from +6 to -2. The sulfur in the sulfuric acid has been reduced, which means that it was an oxidizing agent. All right. The sulfuric acid contains this sulfur which gets reduced. That means the sulfuric acid was in there to act as an oxidizing agent. We're going to look at this topic a bit more closely later on. If you're unsure of that, you can look at it another way. The iodides have gone from -1 to 0. The iodides have gone from -1 to 0, have been oxidized. Well, to oxidize something, you need an oxidizing agent. The sulfuric acid has oxidized the iodide. It's an oxidizing agent. All right. Luckily, we have got another year of looking at things like redox, so this isn't the end of it, but you do need to really engage with this topic and try to get your head around it, because it isn't that bad once if you really, really try hard. Okay. Sodium bromate. Now, bromate to me, just out of interest, bromate means a bromine and oxygen. The V, the 5, Roman numeral 5, refers to the oxidation state of the bromine. All right. Bromate means bromine and oxygen, so it's got bromines and oxygens. Oxygen is always -2, so the bromine must be +5. So actually, you look down here, and hopefully you can see that bromine there is +5. That's where the V comes from. Is a primary standard. This means that the solution can be used to check the concentration of other solutions. Okay. Haven't seen primary standards mentioned for a while, but it's interesting. Doesn't make the question any harder. The half equations for the reaction between bromate ions and thiosulfate ions, bromate ions, and these must be thiosulfate ions, in the presence of acid, there's the presence of acid, are. So here's a half equation focusing on one of the reactants, and here's another half equation down there focusing on the other reactants. So if we can put these two halves together, we'll have a whole. So all you need to do is, when we're balancing half equations, I mentioned this before, you look at the two halves and you look at the numbers of electrons. There are 2 electrons here, there are 6 electrons here, so I'm going to multiply this top equation by 3. So this is also 6 electrons, this gets a 3 in front of it, and this gets a 6 in front of it. I would write over these in the exam, because it's just easier than writing it out again. So, just going to put all the reactants together. That's 6S2O32 minus, plus BrO3 minus, that's you, plus 6H plus, I'm going to cancel the electrons out now because I don't need to put them in, makes 3S4O62 minus, plus Br minus, plus 3H2O. Piece of cake. It took me less than a minute, even with explanations. All right. Next. You know what? Because I haven't prepared myself for these questions, I'm going to come back to the calculations. You're probably all at home thinking, that's the one I wanted him to go through. A laboratory technician decided to use... Oh, you know what? It looks fine. It looks fine. I'm going to do it now. My calculator's on my phone, and my phone is recording this. I'll do what I can. You might have to finish it off. 6S2O32 minus. So we're using the equation that we've just come up with. BrO3 minus plus 6H plus makes 3S4O62 minus plus Br minus plus 3H2O. Right, a laboratory 3H2O. A laboratory technician decided to use a 5 mole per decimeter cube solution of sodium bromate 5. Where are you? That must be you. Concentration 5 times 10 to the minus 3. To check the concentration of a sodium thiosulfate solution that was labelled as 1 mole per decimeter cube. So we don't know for sure that it is. So its concentration sounds like it's unknown. The sodium bromate 5, which is this that I'm pointing at, was placed in the burette, and 25 of the sodium thiosulfate, that's the U then, 2500, was pipetted into a conical flask. Cool, so I've got a V here. Use the concentration of the sodium thiosulfate solution to calculate the so it's saying you need to use this concentration. All right, so I've used this to calculate the expected Titer value. All right, so that's what they're asking you to calculate. All right, so just getting your head around the question. So you do CV over 1,000, that'll give you a moles. You then go across by using a 6:1 ratio, that'll give you the moles here, tick, tick. Then all you're gonna do is do moles times 1,000 divided by C, which is 5 times 10 to the minus 3, and that'll kick out this answer. Yeah, piece of cake. Right. Next, question 12. Students oxidized. How many have I got here? How many questions have I got to go through? Gee whiz. Sorry, everybody, I gave you so many questions. Anyway, students oxidize a solution of hydrochloric acid, HCl, with a few drops of sodium chlorate 1 solution. That's that. The reaction mixture effervesced, which is just posh for meaning fizzed, until it turned pale green. The gas formed bleached universal indicator, so the gas is chlorine. All right. So you say, yeah, anyway. Half equation for chloride ions, the chlorine gas. So write down any elements you're given. Chloride ions, the chlorine gas, 2 of them. 2E minus, done that one before. Write a half equation for the half equation. We go for our rules. Res rule half. For the reduction of these to chlorine, right? So 2 chlorine means I'm forming Cl2 from chlorate 1 ClO minus. So step 1 is to do that, it's to write down anything that you're given. Step 2 is to balance any elements that aren't oxygen or hydrogen. 2 chlorines, I need 2 of these. All right, a lot of people would miss that step. Balance any oxygens with water, 2 oxygens on this side. That means I'm going to need 2 waters on this side. I've now introduced 4 H pluses, 4 hydrogens, sorry. So I'm nearly there, I just got to look at the charges. 4 plus 2 minus, so this side is 2 plus, and this side is 0. So I'm going to need minus 2 on this side to make them equal. 2E minus tick. I'm going to say I've got that right. I will check it because I am going faster now. That is because I can hear my daughter has woken up upstairs and I need to go and sort it out. So what question was that? B. 4H plus 2E minus. Yay! Right, last question. Combine the 2 half equations. All right. So combine the 2 half equations. Look at this. Straight away I can see this is going to be an absolute doddle because you've got 2E minuses and 2E minuses there. So it's perfectly fine just to combine these together. So I'm going to put an arrow in the middle, always helps. 2Cl minus plus 4H plus 2ClO minus makes Cl2 plus 2H2O plus plus Cl2. All right, this needs neatening up. All right, so I've got 2 Cl2s on this side, that one and that one. I've got 2 H2Os there, 2 ClO minuses, 4 H pluses, and 2 Cl minuses. Now, that would be accepted in an exam normally because they would say you can accept multiples, but I do realise that 2s and 4s can all be halved. So really, you could say Cl minus plus 2H plus ClO minus goes to Cl2 plus H2O. It's just always worth looking to see if you can neaten up the equation and make it as simple as possible. Right, next. Question 13. This question is about Group 7 chemistry. Seawater is a major source of iodine. Iodine is I2. The iodine, I2, is extracted from seawater, is impure. It's purified in a 2-stage process. All right. Whatever. Iodine reacts with water and SO2 to make this. Then, okay, whatever. Straightforward. Give the oxidation state of S in SO2. Oxygen is -2, so -2, -4. Sulfur must be +4. Oxidation state of sulfur and H2SO4. -2, -4, -6, +6. You know, when you get good at them, you're given 2 minutes to do that, and it's taken me literally 5 seconds to do. All right. So when you get good at chemistry, it becomes really, really straightforward. If you're sitting there in the exam going, "Oh man, oxidation states, they're so hard. Oh, I hope I get this right." you haven't worked hard enough. I can't make that clear enough. All right? If you get these wrong, you haven't worked hard enough. You've got to break the back of this so you can get that right every single time. I cannot make that clear enough. So now you're sitting at home in your rooms during lockdown. You think, oh, if only I had time to get my head around this. You've got time. Sort it out, please. State in terms of electrons what has happened to chlorine in stage 2. So stage 2, straight away I'm going to go oxidation states because I'm good at them. 0, -1. What's happened if it's gone from 0 to -1? It's gained an electron. Gained an electron, does it once? Gained or accepted electrons, it says there. Yeah, gained electron. Okay, because it's gone from 0 to -1. Alright, when concentrated sulfuric acid is added to potassium iodide, iodine is formed. There's iodine. In the following redox equations, balance the equation for the reaction that forms sulfur. Oops, there's my charger. Sorry about that. Charger fell out and pulled the phone. When concentrated... right, how am I going to balance this? I hate balancing stuff because, especially when other people are watching, because it's going to be a pain. So do you know what? I've told you to do this in the exam before. I'm going to put a star next to it and come back to it later. Because I've only got a minute to balance this, really. Yeah, I'm picking up marks like mad throughout the paper. And there's a chance I could just get, I could come back. I've got time at the end of the paper. I could sit here trying different combinations. There's probably a really cool way to do it, but I haven't looked at it. I haven't prepared before, so I don't know the cool way to do it. So actually, because I've got a limited video, I'm going to leave it. Ha! Nothing you can do about it. Deduce the half equation for the formation of iodine from iodide. I'm getting good at these, because I draw the arrow first, because Dr. Norton told me to. The formation of iodine, I2, from iodide, which is I-. Alright, first thing then, so we've done that. Then I balance the elements. There's no hydrogens, no oxygen, so then I put 2E- on this side. Boom. Deduce the half equation for the formation of hydrogen sulfide. Well, hydrogen sulfide, it says up there, is H2S. Oops, should have done that first. H2S from conc sulfuric acid, which I know is H2SO4. One sulfur, don't need to do anything there. 4 oxygens, that means 4 H2Os. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 hydrogens, and there's 2 hydrogens already on this side, so I'm going to need 8 H pluses. Balance the charges. 8 plus is plus 8, this is 0, so I'm going to need 8 E minuses. Boom. Right, keep saying boom, because it's that sort of thing, isn't it? There's 3 marks here. I'm not going to get hung up on that. All right? I'm not going to get hung up on that.